Welcome to the notes on the greatest common factor, or as I call it, GCF. Okay, so what is a factor? Okay, so easiest way for me to explain it is to give an example. So if we look at the number 24, what are some factors of 24? Well, factors mean that they're whole numbers that multiply into 24. So 1 and 24 are factors of 24 because 1 times 24 is 24. 2 times 12. All right, so 2 and 12 are factors of 24. 3 times what? Well, 3 times 8 is 24. So 3 and 8 are factors of 24. And I think the last time would be 4 times 6. So 4 times 4 and 6 are factors of 24. So you see 24 has a lot of factors, but they're whole numbers that multiply into the whatever number that we're talking about. So in this case, 24. So how are we going to use that? All right. Well, greatest common factor. So the name tells you what it is. We're going to find the GCF of sets of numbers. So we look at our first example, 28 and 40. And at first, if you have to list out the factors of each number, that's okay. To find that GCF or the greatest common factor, go right ahead. So obviously, we got 1 and 28. I can space them out. We know that 2 goes in there. 2 and what? We got 2 times 14. And other numbers of factors of 28. I think 4 and 7. So there's our factors of 28. Now we've got to list out 40. 40 I think's got quite a few. We got 1 and 40. We got 2 and 20. Now right there's a common factor, right? This has a 2, this has a 2. But we want the greatest common factor. So let's keep going because there might be more. All right, no 3. How about 4 and 10? So there's another common factor right there, 4 and 4. And let's see what else for 40. I think we got one more. I think we got 5 and 8. So there are factors. You can see the greatest common factor of the two numbers would be 4. So in this case, that is our answer. Our answer was, did you find this GCF? The answer is 4, and that's how you get it. Now, you're also going to have to find the GCF in terms of exponents, like in this next example. And again, I think it might help to kind of write it out. We've got our x squared, we've got our x cubed, and we got our x to the 5th. Well, we know that x squared equals x times x. We know that x cubed is x times x times x. And we know that x to the 5th is x times x times x times x times x. So what's the greatest number they have in common? Well, they all have 2 x to the 2nd power. So the greatest common factor in this case would be x squared. And it's kind of, and the way to think about it, it's the smallest exponent that they all have. This one has 2, this one at least has 2, and that one has 2. So the smallest exponent they all have. And we put this example right below it. Just remember, GCF, it's of each common variable. It's a list of all the terms contains the smallest exponent of each common variable. So there may be more than one common variable. So in this case, we've got x to the 5th, x to the 2nd, x to the 3rd, but then we also have y to the 6th, y to the 7th, y to the 4th. So our answer would be right here. It would be x squared y to the 4th because the smallest x exponent would be 2 and the smallest y would be 4. So that's how those work. Be aware of those in the homework. Now the problems are going to get slightly more complicated where you've got a list of exponents and variables and coefficients or numbers, like in this example. So when we look at this example, I think the first thing we notice is they all have an x, and what's the smallest exponent? Well, this 1 here. So we know that our GCF is going to have an x in it. So when I kind of list these out, 6x squared, 10x cubed, and we've got 8x, I know in all of them it's going to be something times x. All right, so I look at 6x squared, 10x, and 8. What's a factor that they all have in common? Well, I know that they all 2x times 3x would give me 6x squared. So there's a 2x. And I know that 2x times 5x squared would give me 10x cubed. And I know that 2x times 4 would give me 8x. So my GCF in this case would be 2x. So that's how these problems are going to work. Again, if you need to list out the factors of each number, go ahead. Now, we're going to get into factoring each polynomial. So it's going to be a little different here. All right. But again, all we're going to do is factor out the GCF. Again, as you progress, you'll do these faster and faster. But I look at 8 and 14. What are some common factors? 8's got 4 and 2. 14's got 7 and 2. So I think 2. Well, because I know that this really equals then 2 times 4x would give me 8x. And then I have plus 2 times 7 would give me 14. So I know I can take out a 2. Now here's the key. This is how you're going to have to rewrite these. Since each term has a 2, I take it out. It's kind of the reverse of distributing. So I'm taking a 2 out of the 8x and the 14. Well, then what would be left? Well, if I take out a 2 from 8x, well, I'm going to be left with a 4x. Again, I'm taking out this 2 right here. What am I left with? It's a plus sign and 7. So this is how our answer looks. I factor out a GCF. I take out the 2. What's left? Notice, I started with 2 terms. I better have 2 terms inside my parentheses. All right, so kind of keep that in mind. But that's how you're going to factor out polynomials. Let's do 2 more quick examples, and we'll be good. All right, the next one, 3 terms. All right, now if the leading term is a negative, all right, the first thing that you might want to do is just take out the -1. All right, as you get better, you can do it in one step. But so right now, I'm just going to rewrite this as -1. Then I'll put the parentheses. If I take out a -1, -1 times what would give me 9? Well, that'd be 9a to the 5th. So now that, because we want ideally that leading term inside to be positive. All right. So -1 times what would give me positive 18? Well, negative times a negative would give me a positive. And then -1 times what would give me -3? Well, -1 times a positive would give me 3a. Notice when you take out a negative, the signs, look what happens to the signs. They switch. Positive becomes a negative. So anytime you take out a negative, those signs inside better be a switch. And even right here, this negative became a positive for that 9a. So once I take out the -1, now let's see what we've got inside. What goes into 9, 18, and 3? Well, 3 only has 2 factors, 1 and 3. So it's not 1, so it's got to be 3. I usually look to that lowest number, and that'll kind of tell you what the GCF is. So in this case, it's 3. Now let's look at the A's. I've got 1A right here, so I know it's going to be, I've got the -1, but that's going to be times 3A because I'm taking out a 3A. So this is going to be -3A on the outside. What's left on the inside? Well, I took out 3A. I took out a 3A from this 9A to the 5th. Some people say you think of it as dividing, or you divide by 3A. Or just think of it as 3a times what is 9a to the 5th? Well, that's going to be 3a to the 4th. We've got the minus, all right, 3a times what is 18a squared? That's 6a. And then now, I took out a 3a from this last term. Okay, -3a times what would give me positive 3a? Well, it's going to be -3a times 1, all right? Oops, sorry. Yes, -3a times plus 1 would give me back to my original -3a. So there you go. That's how you do these problems. And then you can see there, that is factored correctly. All right, last example and we'll be done. Now notice, it looks a little different, but there is a common factor. This has an x plus 3, and this has an x plus 3. Each term has an x plus 3. So that means I can take it out. So I'm going to take out that x plus 3. I'll put it in parentheses. Well, I have 2 terms, 1, 2. So I better be left with 2 terms. It's a plus. Well, what's left in this first term? This first term right here, there's a 5. So that's going to be a 5 here. What's left in this term? A y. So when I rewrite this is my final answer. I take out the x plus 3. I'm left with 5 plus y. So there's several examples on how we're going to factor and use the greatest common factor.